Hi guys, welcome to Deep Diver. In today's video, we will discuss an interesting concept called closure, which is not generally present in other programming languages like C++ and Java. So let me go to my VS Code and create the folder and file required for the coding. So this is my Golang course folder. I will create one more folder inside this 15 underscore closures, and inside this newly created folder I will create the file closures.go. As usual, I will add the package main here and the function main. The prerequisite of this video is you must be aware of two concepts. First is function as first class citizens, and second is escape analysis. If you are not aware of these two concepts, please stop here and watch videos on these two concepts first. You can find the videos on these concepts in my Golang playlist as well. Let's start now. So normally a function can access its local variable, global variable if any, and the function parameter, right? But closure along with these three can also access variable from its surrounding. Okay, so let me give you the definition of a closure. So a closure is a function value that captures and retains access to the variable from its surrounding scope even after that scope has finished execution. Okay, so please note the term function value here. So this is coming from this concept function as a first class citizen, which basically means functions just like other type of values, integer, string, etc. are also treated as values. Okay, so let me explain this through an example. Let us say we have a variable x and we initialize it to a value 100. Okay, and we create one more variable fn and we assign a function value to this fn variable. So let us say we have a simple function and here we are trying to print the value of x. Value of x. Okay, now let us say we call this function like this. Okay, so what we are doing inside this function value, we are accessing the variable x which is not in the scope of this function, but this x is present in its surrounding scope. Okay, so this is an example of closure where we are trying to access a variable which is not in this function scope. Okay, so now let me try to run it. I will open the terminal. So go run closures.go. So you can see here this is printing the value of x as 100. Okay, so this is one of the example of closure. Now let me add one more line here. X is equal to, let us say, 1000. Okay, and now what should be the output? Let me run this code again. Go run closures.go. So this time it is printing 1000, right? Why? Because a closure is a function value that captures and retains access to the variable, not the value. So when we are trying to print the value of x here, it is not capturing the value, but it is capturing the variable. Okay, so whatever the modification we do on this x before calling this function, that will be reflected by this function. Okay, so if we assign x to some other value, let us say 2000, then in that case what will happen? The value will get printed will be 2000. Okay, now let us look into the next example of closure. So let me comment this code and I will introduce a new function here. Let us call this function counter, and this function will return a function value. Let us say it returns a function which looks like this. Okay, and inside this counter function will have a local variable count which will be initialized to 0, and then we need to return this function value. So inside this function which we are returning, this will just increment this count by 1 and then it will return this incremented count. Okay, so this is our counter function. Now let me try to use this function in our main. Okay, so let us say I create one variable inc which is short form for increment and then call this counter function. So what this counter function will return? it will return this function, okay, which is basically a closure, right? Because here it is trying to access the variable count, which is not in this function scope, but it is present in its surrounding scope, okay. So this counter will return this function, and let us say we call this function like this, inc brackets, okay. Let us have this print statement two more times, and if I run this code again, go run closes.go, what should happen? So let us try to trace this first. So this counter returns this function, right? And then we are trying to call that function. So it will try to execute this, okay. When we call this counter function, count was initialized with 0, and after that through this inc we are just calling this part, okay. So every time this inc will get called, count should get increased by 1. So for the first call of inc it should print 1, then 2, and then 3, right? So let us verify that. If I run the code again, you can see 1 2 3 as expected, okay. Now let me ask you a question. My question is, this count variable inside this counter function, this will be allocated on a stack or heap? If you have watched my video on stack, heap and escape analysis, you may be able to answer this. So let us do the escape analysis and decide. Let us suppose this count is allocated memory on the stack frame of this counter, okay. Once we call this function here on line number 27 and this counter function finishes its execution, what will happen? The stack frame corresponding to this counter function will be removed from the stack, and consequently the count variable which we have assumed to be allocated on the stack frame, that will be removed from the stack as well, okay. So when this inc will try to access this count variable here, this count is no longer valid as the variable is already removed from the stack, okay. So here the Go compiler will come into the picture and will do the escape analysis and will decide this count is not safe to allocate on the stack, and it will allocate this count on heap instead, okay. So this count will be allocated on heap. Let me show you the escape analysis done by the Go compiler here. So we will use the command go build minus gc flags is equal to minus m, and we'll pass this closes.go here, and here you can see it is telling on line number 18, which is this, right? So on line number 18 moved to heap, so this count variable was moved to heap by the compiler, okay. Now let us move forward. I will copy this code and paste it again, and instead of inc I will replace it with inc2, inc2 and inc2. Now my question to you is whether this code will print 1 2 3 4 5 6, or it will print 1 2 3 and then again 1 2 3. Let us trace it out. So for this first 4 line we know it will print 1 2 3, but what about this last 4? So when this counter will be called again on this line number 32, what will happen? This entire code has to be executed. So again count will be initialized to 0, and this will again escape to heap. So at this point of time corresponding to this count, we have two variables in the heap. Maybe internally it is getting represented at count 1 and count 2, but long story short, we have two variables corresponding to this count variable in the heap corresponding to these two invocations, okay. And when this 33 to 35 will execute, it will increment the count by 3, right? Here it will get incremented by 1, then 1 and then 1, right? So again it will print 1 2 and 3. Let us try to verify that. I will run this code again, and you can see it is printing 1 2 3 and again 1 2 3, right? Now let us see the last example. I will comment out this code, okay, and uncomment the previous code. Here I will comment this, Now here what I want to do is I want to create one more closure which will be accessing this variable x. Okay, so let us name this variable as dec, which is short form of decrement, and here we will just decrease the value of x. Okay, x minus minus, and then we will use this decrement variable to call this function. Let me get rid of this unnecessary space. So here what we are doing, x is initialized to 100. We have created a closure which is just printing the value of x, and we have created one more closure which is just decrementing the value of x, and then we are calling decrement, and then we are calling this fn. Okay, so what should happen, this decrement should decrease the value of this x by 1, and that decreased value should get printed here. Why? Because the closure captures the variable, not the value, right? So let me add this decrement one more time here. Okay, so if I run this, go run run closures dot go, see it is printing value of x at 98. So that's it for this video. See you in the next one.